Guide me on the great Jehovah, pilgrim through this barren land. Hey, I am weak, but thou art mighty. Hold me with thy powerful hand. Singers, help me say, guide me on the great Jehovah.
Welcome to my channel. My name is Luku Dennis Kwesi, and I basically want to welcome you to this basic and quick lesson. There is this software, this ekts is an electromechanical software which is used for electrical programming, for basic electrical programming or drawings. And so, as a new student, when I was done with school, I needed a software to help me out with certain stuff, like a basic say forward and reverse connection of a motor. And it also offers you the ability, or offers you animations abilities, so you see the motor moving. So if you say you don't have the real device, a motor to connect, you can construct such a circuit, and you get the feeling of a forward direction or a reverse direction. You can also construct a star delta with this software. It offers you a lot. So today it's just a quick introduction to what the software is all about and a basic circuit. Okay, so to construct a basic circuit, you go to File, you choose New. It will open up a new interface for you to construct your diagram. So today we are doing a simple thing, like I said earlier, which is a direct online circuit to control a three-phase motor. So what do we need? We need a three-phase supply. Double click on it, it gives you a three-phase supply over here. So from from the power supply, you need a contactor. Over here you see normally open triple contact. This is a normally open contact, but we need a normally open triple contact. So you double click on that, it appears over there. And to get options, you hit on it, right click, it gives you rotate. You rotate to a 90 degrees, and there you have it. If you put your cursor close to the end of it, it gives you a red dot, which means you can construct your wiring. So you click, left click, extend it to meet this one. It gives you another dot, you leave it, then it joins. So same thing applies here and here. So when you double click on these three dots, it moves it around. But we'll be doing some taggings. We'll be doing some taggings later, so we'll get into why the dot moves and all that. You double click on it and you try to reconstruct your lines properly. Okay, what we need next, from the power supply, which will rest inside the contactor, when the contactor closes, it goes to the motor. Let's now not connect any overload to the system, or better still, you can still connect an overload, which is also a normally open triple contact. So you hit on it, you bring it the right click, rotate, and you join. I hope you are following. Okay, so let's now bring in our motor. Over here you see induction motors, single phase induction motor, single phase induction motor with centrifugal switch, star delta, and we just need a simple three-phase induction motor. So we choose that, we bring it over here, and we also do the connection to join the circuitry.
So listen, it reaches to the high.
All right, so there you have it. So that's the power circuit. Let's now go and construct our control circuit. Okay, so with our power circuit, what do we need? We need a close push button for the stop and open push button for our start. And we need a contactor. So over here is the contactor. Let's click. We need a stop. We also need the start. Then we need our stop. We need a neutral to close the circuitries. And so let's construct our control circuit. So how did it? That's our contactor. Okay, let's rotate all this 90 degrees. Rotate this also. Do a rotation for this too. And then let's join them circuitry together. Okay, so I hope you are following our circuitry. It's a basic direct online circuit. So let's pick a power source from this point. There you have it. And we are actually done. One thing we need to do with this contactor, what we want to happen is that when this contactor closes, this very contactor closes, we want this contact to close. So we need to tag this contactor to have the same tagging with this ones. I hope you get it. So if you click on this triple dots twice, it opens a tag for you to label the contactor. So let's label it as say C1. All right, hit your enter. So when you come to this contactor, if you double click on the dots, it gives you that option to choose. And so now whenever this C1 works, it has that effect on this. And since this software doesn't give us a normally or an overload, it doesn't give us an overload. I'm actually using a triple normally open contact as overload. So I need to also tag it using the same contactor tag, such that if the contactor closes, we assume the overload has also closed. I hope you get it. Yeah, so we are actually done with our circuit. So you hit on this play button and then you are in your simulation mode. So let's press our start. As you can see, as I press the start, the motor rotated. Let me do that again. If I press and hold, you can see the motor is rotating. If I leave it, it goes off. Why? Because we've not done a latch for the controls. We need to construct a latch so that the motor holds on whenever we hit the start button. So how do we do that? We need a normally open contact again. First of all, you need to stop. Then you choose your normally open contact. Now, normally open contact is actually for this contactor. Alright. So let's rotate again. And then what happens is that we want our circuitry to still function just by clicking on the start and releasing it. So let's label this also as our C. So let's see what happens. Our circuit now holds on, because what happens is that Current continues to flow through this path and into the contactor, keeping the contactor closed. If you hit the stop button, the circuitry doesn't stop. So we've made a mistake somewhere. We need to delete this. And then join it at this point. So let's test again. Hit start, hit stop. Thank you for watching. Bye bye.